All right, this video is for the lesson 9.1 homework. We're looking at the pieces of an exponential function today. So just what the different pieces mean, what they represent. All right, so number one, what is the name of a function in which the independent variable x is in the exponent, denoted by f of x equals a times b to the x? So anytime that our variable, the letter, is up in the exponent, we know this is an exponential function. Okay. And then number two, what is the name of the value that represents the y-intercept in an exponential function? This is the a value. So when we write one of these functions, this number that comes first, the number that doesn't have the exponent, that's actually your y-intercept. So again, exponentials are a lot simpler than the quadratics were. We don't have to do as much. We don't have to go into as much depth with them. All right, so here's what we're going to do. They're going to give us the function, and we're going to identify the a value, the b value, and the growth rate or the decay rate. So quick exponential functions. So if I've got a graph, if it's exponential growth, it does something like this. As x increases, y increases, it gets bigger and bigger. This is like interest on savings accounts or interest that you pay on loans is exponential growth. Decay goes the opposite direction. As x increases, y decreases. Okay? And usually the x is the time. This is like the value of your car. You guys know how that works. You buy a car for $20,000. The next year it's only worth 19. Then the following year it's only worth 17, and then 15, and then 10. It keeps, that value of that car keeps going down and down over time. As time increases, value decreases. That's what a lot of these are, is value. There's some other different ones in here, but. All right, so number three, the population of a town is increasing according to the function f of x equals 3,200 times 1.04 to the t power. So the a value is the number that's outside the parentheses. So we're just going to write that down there. The b value is the number in the parentheses. And then to determine if it's growth or decay. So this one is increasing. So that would be growth. And how I determine that amount, I'm going to take the b value and I'm going to subtract 1 from it. So you can do this in your calculator. And then I got to make it a percentage. So to make a decimal into percentage, I multiply it by 100. Okay, so to show you what all of that would look like in your calculator. So if it's growth, I'm going to take the b value, I'm going to subtract 1, and then I'm going to multiply it by 100. And that means the growth rate is 4%. And it's always going to be a 1. You're always going to subtract a 1. That's just how percentages work. Okay? So what this equation does, if I type this equation in, say, into one of my graphs, 3,200, 1 times 0.4, and then I got to change the exponent to an x. And then if I look at the table, any of these x values is going to tell me the population of that town. So after 1 year, there's going to be 3,328 people in that town. And then I could go to 10 years. After 10 years, there should be 4,736 people in that town. That's how these functions work, is they help you kind of predict what's going to happen. All right, number 5, Harry invests money into an account that increases exponentially according to the function f of x equals 500 times 1.025 to the t power. So the a value is the first number. B value is the number in the parentheses. And then it says growth or decay. So again, it's increasing. So that's growth. So we take that B value and we subtract 1. So 1.025 minus 1. And then we multiply it by 100. So that equals 0.025. And then we multiply that by 100. And we get 2.5%. Okay, so your 2 over here, 4 and 6, they're both gross. They're all grouped up together, so they're kind of easy to keep track of what you're doing. All right, number 7. Due to a severe drought, the population of lions in a game preserve is decreasing. According to the function, f of x equals 80 times 0.965 to the t power. So the a value is 80. That means when we first counted these lions in this game preserve, there's 80 of them. And that amount's going to keep getting less and less every year. Okay, so again, your A value is your starting amount, your y-intercept. When you start the count or you start the prediction, that's what you're starting with. Your B value is the number in parentheses. Now this one is decreasing, so it's decay. So to find that as a percentage, we do 1 minus that B value. So we just kind of flip the numbers around. It's still subtraction. We just have to do the 1 first. Now, you can do it this way, minus 1. Okay? You get a negative answer. So it depends on how they want the answer. Okay? But if we're identifying it as decay, we don't need it to be a negative percentage. So typically we keep our percentages positive, but just so you know, a percentage can be negative, and that just indicates that it's decaying or decreasing. And then we multiply it by 100. So that process is the same. So it's decaying at a rate of 3.5% every year. So every year, 3.5% of the lions are going to die or get hunted or something on this game preserve. All right, number 9. A new computer depreciates in value each year according to the function f of x equals 1,500 times 0.82 to the t power. So the a value is the first number. So 1,500 would be how much you bought that computer for. $1,500. Okay. 0.82, that's your b value. That's its rate. And then depreciates means it's decaying. Okay? So we would do 1 minus 0.82. And we get 0.18, and then we multiply that by 100. Times 100 would be 18, and we write it with the percent sign. So that's all that I'm asking of you today. Pick out the pieces. So 8 and 10, those are both decay. So the top 2 are growth, the bottom 2 are decay.